Math with Mrs. Peters, the crazy cat lady of Hiram High School. Today's topic is the binomial expansion theorem. And what we're going to do is we're going to look at a couple of parts in a binomial expansion. A binomial is two terms. Okay, so there's my binomial. And I want to expand it when it has an exponent of, I don't know, say 15. Right? That's a binomial, and I want to expand it so I don't have to do, and I want to take a shortcut, y'all, because I don't want to have to sit here and do 15 of these binomials and do my little boxes and do all that multiplication. I'm into shortcuts sometimes, especially when they're math shortcuts. So this is one that all mathematicians approve of. So with that said, let's talk about Pascal's triangle. Pascal's triangle says it's this like sort of like a sieve, and as you can see, this sort of looks like a triangle. But what I'm doing, okay, is I'm always going to start off my triangle with ones right here, and I'm always going to have ones on the outside edges. These are all ones. Now, in order to fill in my triangle, okay, is I am going to add, okay, the previous. I'm going to add these two right here, and that gives me what fills in this little hexagon. Okay, so 1 plus 1 is 2. In order to do this hexagon, I'm going to say 1 plus 2 is 3, and 2 plus 1 is 3. And as I go here, I get 4, 6, 4. Now I want you to sort of see, we have some symmetry going on here. That's sort of cool. So the next level here would be 5, 10, 10, 5. And what I want you to notice is that we have a line of symmetry going up and down through my um, triangle, my Pascal's triangle. And the clue is you add the two sides to get the one down. Now, what this would look like if I didn't have my little hexagons is I'd have 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. And these numbers are going to be very helpful. We're going to want to know what level of Pascal's triangle we're on, okay? And this level, this number here, is going to correspond to the exponent. So our level corresponds to the exponent on our binomial. And remember that very first one that I started out with over here? My level would be the 15th level. And no, we're not going to expand this one all the way out. I promise you that. So, now, the binomial expansion. It is a shortcut for a lot of work. And y'all have seen the circle and the boxes before. All right. So when we've done the difference of two squares or the sum of two squares or any of those patterns that we used when we were factoring. So what I want us to do is we're going to look at a shortcut. Okay, we're going to have to know what's in the circle and what's in the box. Okay, this is what our standard term looks like. Each one of our little terms in our expansion is going to have a blank spot here. It's going to have a blank. It's going to have a square raised to some sort of power. It's going to have a circle raised to some sort of power. Now, the n, or the exponent on the box, is always our shrinking exponent. The exponent on the circle is always our growing exponent. In other words, it's getting bigger. N is getting smaller as my growing exponent is getting bigger. Now, what goes in on the line is something from Pascal's triangle. What goes in the box is the front term of my binomial. Okay, what goes in the circle is our back term of our binomial. Now, let's take it apart and let's look at an example. Okay, I have my binomial is 2x plus y raised to the 5th power. Well, n is 5. My front term is 2x. My back term is y. And the fifth row of Pascal's triangle is 1, 5, 10, 10, 5, and 1. So that means I can start filling in some pieces. Let's put in the fifth row of Pascal's triangle on our little lines. That would be 1, 5, 10, 10, 5, 1. Okay? Now, let's put in our growing exponent. Remember, my growing exponent's on the box. So that would be 5, 4, 3, 2, 1, 0. Let's put in my shrinking exponent. Excuse me, my growing exponent. We just did the shrinking exponent. Gee, Mrs. Peters, let's get your brain together. Okay, so I'm going to start with 0, 1, 2, 3, 4, 5. Now, if you add up the exponents on each term, it should equal whatever n was, which was our original exponent. Now, let's put in the front term and the back term. My front term is 2x, so I'm going to put in 2x wherever I see that box. You're like, oh God, Mrs. Peters. Look, all we're doing is filling stuff in. This is not that scary. We can do it. We can use calculators to help us do the calculation part. Okay, now let's put in our back term, which was y. Y. Now, we're going to take each term and we're going to look at it and we're going to do a little bit of multiplication. I have 1 times 2x to the 5th power, y to the 0 power. All right, so this is 1 times 2 to the 5th power, which, let's see, that's 2 times 2, which is 4, times 2 is 8, times 2 is 16, which is 2 is 32. This is 1 times 32 x to the 5th times 1, because y to the 0 power is 1. Okay? My next term, well, this is 5 times 2x raised to the 4th power times y to the 1st power. So this is 5 times 16, I'll do it this way, times 16 x to the 4th, y to the 1st. Let's do the next term. This is 10 times 2x to the 3rd, y squared. So this is 10 times 8x cubed, y squared. Let's do this again. Let's do my next term, which is 10 times 2x squared, y cubed. So this is 10 times 4 x squared, y cubed. Okay, this is 5 times 2x to the 1st power, y to the 4th power, which is 5 times 2x, y to the 4th. And here comes the last term. This is 1 times 2x to the 0 power, y to the 5th power, and anything raised to the 0 power is 1. Now, let's finish out our multiplication using our calculators, because we all know Mrs. Peters can't calculate without her calculator, because I hate to tell you guys, but 5 times 16 is not something I can do in my head. So, let's look at some of these. Okay, 1 times 32 is 32 x to the 5th, plus 5 times 16 is 80. So this is 80 x to the 4th power, y, plus 10 times 8 is 80 x cubed, y squared. plus 40 x squared y cubed plus 10 x y to the fourth plus y to the fifth. And we have right here, here is my binomial expanded out without having to do all those little multiplication boxes that we all complain about. Now, I have one for you to do. Go ahead and fill it out. Try it. It's only to the fourth power, so we know what n is. You know what the front term is. You know what the back term is. Fill it out bit by bit by bit. And I know y'all can do this. And if you can show me that you can expand this out to the fourth, I'll show you what happens when you're expanding something like x plus y to the 18th power and you want the third term. So that you don't have to build out Pascal's triangle to the 18th level, because there is a handy duty shortcut to find the coefficient, but I'm not telling you until you can do a problem like this. So, with questions, write them down, show me them, talk about them in class, and I know y'all can do this. I'm so proud of you. Take care. Bye-bye.